So today we are going to talk about the most basic and fundamental concept of ECE, such as voltage, current, and resistance in series and parallel circuit. So in every circuit, there is an input node and an output node. So in series, supposedly we applied a voltage, which is we call the V input or the voltage input, to a circuit which has two resistances in parallel. So the resistances in parallel will be equal to resistance total is equals to R2 plus R1. So the current in a series circuit, or here, the current on a series circuit, which is called I in and I out. So I in, or the input current, will be equal to the I out. So it means that the amount of current flowing to the R2 and the R1 is basically the same. So in voltage concept, the voltage or the total output voltage will be equal to the input voltage. So as knowing the concept or the relationship of the output voltage and the input voltage, we can relate that V in is equals to V out is equals to V1, which is found on the resistance 1, and plus the V2, which is found on the resistance 2. So there. So using the formula of getting the voltage 1 and voltage 2, we can use the formula, which is voltage is equals to current times resistance. As knowing that, we can recall that V1 is equals to I times R1, and that V2 is equals to current times R2. So there, that is the basic concepts of series circuit. Now in parallel, there are difference. So in parallel, the concept about the voltage and the current relationship is different. So in parallel, the total resistance is equals to the parallel combination of R1 and R2, which is R1 multiplied by R2 over R1 plus R2. So that is the total resistance on the circuit like this, which is R1 is in parallel with the R2. So the voltages, or the current rather, the current in parallel circuit will be derived as the current going on this node, or the I in going this node, will be distributed in two directions, which is the I1, which is the first direction, and I2, depending on the amount of branches that it will traverse. So there. So in relationship with that, the I out in the other node will be equal to the I2 plus I1. As you can see, all the current flowing in this node will be distributed into this direction, which is the I1, and in this direction, which is the I2. So in the output side, you can see that the same currents are going out. So I1 plus I2. So we can derive it as I in, or the current input, is equals to the current output, which is equals to I1 plus I2. So in terms of voltages, the voltages in this particular branch on R1 is equals to V1 is equals to V2 and equals to the 5 volts input voltage. So using the formula of finding the voltage in the R1 and in the R2, we can compute for the I in first. So if you computed for the I in already and you know the value of I in, we can easily compute the voltages in the first branch, which is the R1, and in the second branch, which is the R2. So using the relationship that we had tackled previously, we can therefore derive that the voltage 1 is equals to I total, or the I input, or the I output. So I total is times the R1, or the resistance 1 in the branch 1, over R1 plus R2. So the same with the second branch, the voltage in the R2, or the V2, will be basically V2 is equals to the I total times R2 over R1 plus R2. So in finding the voltage, you can define that the input voltage is equals to V1 is equals to V2. So now let's recall what we have tackled previously. So in series relationship, R total is equals to R1 plus R2. In parallel, R total is equals to the parallel combination of R1 plus R2. So R1 multiplied by R2 over R1 plus R2. So in terms of current, I input is equals to the I output. So it means that the current is the same all throughout the circuit in series circuit. So in parallel, I input is equals to I out is equals to I1 plus I2. Now the subscript 1 and 2 depends on the number of branches that is present in the parallel circuit. If there are 3 branches, we can say that I in is equals to I1 plus I2 plus I3. So if there are 4, then I1 plus I2 plus I3 plus I4. So in terms of voltages, we can say that in series, the total input voltage is equals to the total output voltages is equals to V1 plus V2. Now again, if the circuit has 3 or more resistances, you can say that V1 plus V2 plus V3 and so on. So voltages in parallel is equals to V input is equals to the first branch, which is V1, is equals to the second branch, which is V2. And if there are more branches, all the voltage is equals to the V in. So using the formula in terms of the voltages, V1 is equals to I times R1, and V2 is equals to I times R2. So in parallel, we can use a voltage divider formula, which is I, or the input current, times the first branch in the resistance 1 divided by R1 plus R2, and V2 is equals to the input current times the R2 over the R1 plus R2. So if there are more branches in a parallel circuit, such as V3, you can expand this equation and put R3 here. So R3. So the V3 is equals to input current times resistance 3 over R1 plus R2 plus R3. So that is the most basic concept of ECE. So thank you for watching, and put a thumbs up and subscribe.